Hey there, this video is about segment and angle bisectors. Hey guys, this video is going to seem very similar to the video you watched regarding a midpoint because a bisector has very similar meaning. So a bisector cuts an object into two equal parts. So you can see right here for a segment bisector, essentially it's the same thing as a midpoint. You want to indicate that with the tick marks, the two smaller sections are equal. Couple of ways to notate it. If you don't remember, you could say AB is congruent to BC, or you may simply just see the word bisect. So B bisects segment, whoops, this should be AC. Okay, so really the new piece of information for this video is the angle bisector, because we kind of talked about when you have two congruent angles, you put these little arc marks. So an angle bisector cuts an angle into two equal parts. So instead of a point bisecting a segment, the bisector of an angle is actually a ray. It's this whole thing here. So ray BC. So when you write your notation, it's important to make sure that you use the symbol for a ray, like we learned in one of our very first videos. So capital letters BC with a little arrow above it bisects the whole angle ABD. If you're not quite sure about what we did regarding the midpoint type of questions, here's a quick little review. Go ahead and jot it down, and then we will go through each part of the problem. So step one is to set up a diagram. So you want to always make sure you read to make sure you're putting the bisector, which kind of is like, it's the same thing, kind of as a midpoint. So if B bisects AC, then B is going to go in the middle. A and C are our endpoints. You want to label each of these smaller segments with tick marks to show that they are congruent. And since they are congruent, I can set their expressions equal to one another. I can go through and start combining my like terms. Once I get my value for x, plug it back into each of the expressions that was given. Right? So you guys remember doing this question way back with our midpoint notes. I'm going to plug x in to check. They should come out to be equal because they are equal. And then to find the total, just add them together. The same type of concept applies for an angle bisector. Okay, so instead of using the tick marks to show congruent segments, we're going to use arc marks to show congruent angles. And our question says that ray BC bisects angle ABD. So what that tells us is the two smaller angles must be congruent because this is a bisector. So I'm going to set them equal to one another. And then we can solve for x. So 3x equals 15. Divide both sides by 3. X equals 5. You can always check this by plugging your value for x back into each expression and making sure that they really are equivalent. So if I did that, this would come out to be 51 degrees. And then plugging in 5 here, 4 times 5 is 20, add 31, we also get 51 degrees. So we can check to make sure that we did that math correctly. Go ahead and try example 2, and then when you're finished, you can resume the video, check your work, and see how accurate you were. Example 3. If ray XY bisects angle AXB, go ahead and first of all draw a diagram to represent this situation. So a couple of ways that you can start. I prefer to start by drawing the angle. And always remember the letter in the middle is our vertex. The other two, it doesn't really matter where they go on the sides. And then I want to draw a ray connected to the vertex of that angle, so x, y. So now I'm going to give you some information about this diagram so that you can solve for the missing value. If the measure of angle AXB equals 80 degrees, find the measure of angle AXY. So we're trying to solve for this angle here, AXY, right? And we know that AXB, the entire thing here, is 80 degrees. So again, if this is a bisector, it cuts it into two equal parts, which means that each of those smaller angles must be 40 degrees. Not so bad. Let's try it with algebra. Alright, example 4. Go ahead and jot it down, and then we'll get started. So in this case, they give us the measure of angle ADB. That's the whole thing, kind of like the last example we just did. So that is 106 degrees. We know that ray DC is a bisector, so we can have those little arcs. And now we want to set up an equation. So the relationship between angle ADC and ADB is that ADC is half of ADB. Or you can think of it like ADB is double ADC. So I'm going to think of it like this is half. So if it's half of 106, then it's 53 degrees. So I can set up my equation, and now I can solve for x. Oops. So again, the way that I got the 53 is by taking my total and I cut that in half to get each half, since it's a bisector. Sometimes you will have algebraic expressions for both parts. Like here I gave you a whole number, which was nice. We could just cut it in half. But what if they're both algebra? Okay, here's our last example. And this one's a toughie because now it gives us a bisector of angle ADB, and it gives us an expression for that whole angle. So ADB is 4x plus 38. Now it's asking us to find the value of x and then to find the measure of angle ADB. So again, it's a bisector question. So the big idea of this whole video is that a bisector cuts an object into two equal parts. So even though we're only given ADC is 3x plus 1, really angle BCD is also 3x plus 1 because they are congruent, since this is a bisector. Okay, so now we can, it wouldn't really make sense to set these equal to each other like we did in the beginning problems because they're the same exact expression. So everything's going to cancel out. So that's not going to help us. And don't forget, we have this over here that we want to use somewhere in our equation. So think of the relationship between these three angles. So we've got a total. This expression is double each of these small angles, right? Or this is half of the larger angle. Or we can go way back to angle addition postulate and just say, if I add these two together, it should give me the larger angle. So I'm going to choose the last option. You pick whichever you think fits best for you. Once you have your equation set up, you can go ahead and solve for x, and then plug x into your expression to find the measure of the angle. So we get a final answer of x equals the value of 18. So remember, that's not the angle measure. That's just a missing value that's a placeholder for our variable. So if I wanted to find the measure of angle ADB, I'm going to take that value for x, plug it in here, and simplify. So this should give me 110 degrees for my total angle ADB. So I hope this video helped you guys understand what an angle bisector does. I hope this video showed you that an angle bisector is different from a segment bisector because it's not a point. It is a ray. So anytime you are writing out the notation, you want to make sure that you use the ray symbol, right? And not just a capital letter like we did for the segment bisector.